Let's do a problem on these force calculations on the horizontal and the vertical surface. So geometry is given. So let me just draw it. So this is how it looks. Okay, you have water till here. Water is filled till here. Okay, so this area of cross section is 0.01 meters square, and this length is 4 meters. Okay, so you have this as A, B, C, D. This is 2 meters, and this is supported. Okay, so now we need to find out. So let's write down the question. Find, there are two bits. So find the total pressure and locate it on area AB, which is 2.5 meters wide, and find the total pressure on the bottom of the tank, having area 6.5 meters by 2.5 meters. Okay, so this is the question. Okay, so let's start with A. So on the area AB you need to find out the pressure. Okay, so free surface is somewhere here. Okay, free surface, I mean this is the free surface. So here you have rho g4 is the starting pressure, and rho g4 plus 2, that is rho g6 as the pressure on area AB. So this is a vertical surface, and I can basically use whatever formulas I have derived. So the force, the total pressure was WA x bar. X bar is the distance measured from the free surface to the centroid of the location. So centroid of this will be, this is 2 meters. So centroid of this AB, which is basically a rectangle. So this is 2 meters and this is 2.5. That's what is given. So centroid will be somewhere here. So that is 1 meter from this side, but then the free surface is 4 meters. Okay, so the total height x bar is 5 meters. So W is rho g, A is area of cross section, that is 2 into 2.5. X bar is 4 plus 1, that is 5. So rho g, again I have to write 9810 into 5, that is 25. Okay, so this is how you get. So now you have to basically use the calculator to get this. So we get 245.25 kilonewton is the force coming due to the water. Okay, so that is on the, so how do you find the centroid of the location? We directly use the formula XP, or you can use basically the pressure diagram concept also. So XP is x bar plus Ig by A x bar. So you can just directly use this to get the, so x bar is basically 5. Ig is about the centroid, this, so Ig of about the centroid will be about this axis, which is nothing but rectangle. How do you get the area moment of inertia about the axis? It's basically, if this is B and this is H, it's basically BH cube by 12 is Ig. So 2.5 H cube by 12 is Ig, and so let's substitute all that. 2.5 into 2 cube is H by 12. Area is 2 into 2.5 and x bar is 5. So this comes out to be 5 point. So let's see, 2.5 gets cancelled. This is 4 by 12, 560. So this is 5 plus 1 by 15. So close to almost, so that this many meters. Okay, that is HP bar. So now for the bottom surface is horizontal, right? The bottom surface BC, and that base is horizontal. This is 6.5 and this is 2.5. So it is just the pressure at the bottom is basically rho g H, the total H is how much? 4 plus 2, 6. So rho G 6 is the pressure. So that pressure into area is nothing but the force on the bottom. So this is a horizontal surface, so straightforward. Rho Gx area is 6.5 into 2.5. So you get 9810 into 6 into 6.5 into 2.5. So let's calculate it. So we get 956.5 kilo Newton as the force. So this is a very simple problem. I mean, on the horizontal and the vertical surface it will be given. You have to just use the formula and just calculate it. So let's do a problem on the curved surface. A long cylinder, just write down a long solid cylinder of radius 0.5, radius 0.8 meters, hinged at A, is used as an automatic gate. When water level reaches 5 meters, the gate opens up by turning the hinge. So let me just draw that. Okay, so this is how. Okay, so you have the water level here. Okay, and this distance is 5 meters, and this is basically a cylinder. So perpendicular width is 1 meter. So let's write down. So what is given is when the water level reaches 5 meters, the gate opens up by turning about the hinge at A. So this is point A. So we need to determine the hydrostatic force acting on the cylinder per meter length of the cylinder, So basically perpendicular width, he says you can just take it, and radius is given as 0.8 meters. Okay, so now we'll just adopt our thing. So this cylinder, okay, so what I'll do is, if this is the surface, I'll just project it. I get this surface and this surface. So this is the thing. Okay, this is the curved surface. The water force, okay, so this is my curved surface. This is A, this is B, and the pressure is acting all normal. Okay, so this will result in some FH and FV, which we need to find out, right? The resultant of this FH and FV. What I'll do is, I'll just consider, because I told you I'll consider this volume of the fluid by just projecting this surface AB vertically and this surface AB horizontally, and consider that volume of the fluid. So this volume of the fluid, I'm considering it here. So this is AB. So this is the volume of the fluid. Let's say this is C. So the weight is W. Okay, and now this FH and FV, which is the fluid forces exerted by fluid on the AB, will now, because I am considering the volume of the fluid in ABC as my free body diagram. So I need to represent these force FH and FV, which are now exerted due to the surface AB. So these will be like this. Weight will be W, weight of the fluid here. Now at BC you have some bottom force because there will be some pressure, and you have some force AC because of the left side fluid. So if you do a force balance, so FAC is nothing but FH, and so FH is nothing but FAC, which is the force on that AC. AC is a vertical surface, so vertical surface, this is the free surface somewhere here, the vertical surface is here. So let's find out first the X bar, because the vertical surface is WA X bar. So X bar is basically, so this is 0.8, So till here it is 4.2. So 4.2 plus half of 0.8, so it is 4.6. So if I use that, so WA x bar, A, the projection of this will be 0.8. So W is 9810. A is area of this AC cross section. Perpendicular width is 1 meter. AC is 0.8. So 0.8 into 1 meter into x bar is 4.6. So you got the horizontal force from this. Let's calculate. So this is 36.1 kilo Newton is the horizontal force. Okay, so now I need to get the vertical force. So if I balance vertically, FB plus W is the force at the bottom. So there are two things I need to know here, FB minus W. So let's calculate. First is FPC. FPC is the force that is coming from the fluid, the surface. So it's basically how much this surface is exerting on the fluid. That is nothing but how much the fluid pressure is there into. So fluid pressure at the bottom into area of BC. BC into perpendicular width 1. So full pressure at the bottom is rho g 5 into BC is nothing but 0.8 into 1. So this is force on the BC. Now what is the weight of this fluid? Now weight of this fluid is nothing but that total fluid. I can just write is as total minus this circular, right? So this area is nothing but R into R, so R square. This is nothing but half same quarter circle, so pi R square by 4 is the area of cross section. So R square minus pi R square by 4 is the net area of cross section into perpendicular width, which is 1. So this is the volume. Volume into density is mass. Mass into G is weight. So this is how I get rho G 3 pi R square by 4 is the weight. So I get this when I used it here. So when I substitute this FPC, I get a value 37.9 kilo Newton. So this is the horizontal force, this is the vertical force. The total force that is acting is the resultant of these two. So 52.3 kilonewtons. So the idea is simple. Whenever you have a curved surface, take the curved surface, project it vertically, you get the vertical face, and project it horizontally, you get the horizontal face. Now consider the volume of the fluid as a free body diagram in that and put up the forces. So the forces FH and FP which are exerted by the fluid on the curved surfaces, they will now act in a reverse direction, because these will now become the forces exerted by the concrete surface on the fluid, and you are drawing the fluid surface. So then consider the weight of the fluid, don't forget that, and then just balance Fx, because it's a static fluid, static equilibrium. So balance forces in X and balance force in Y, you get the answer. Thank you.